Writing code is easy, but writing good and quality code is hard. In the quest for writing high-quality code, software engineers have embraced various architectural and design principles. A principle is an abstraction, a guide to design. A pattern is an implementation that solves a particular problem. They do not provide implementation guidelines and are not bound to any programming language. Among these principles, YAGNI, or you ain't gonna need it, KISS, keep it simple, stupid, DRY, don't repeat yourself, and ETC or ETC, as I like to say it, easy to change, stand out for their ability to promote clean, maintainable, and efficient code. Understanding and applying these principles can significantly improve the readability, maintainability, and performance of our codebase. Today, we'll delve into each principle, exploring their definitions, benefits, and practical implementation strategies. We'll start with the YAGNI principle. The "you aren't gonna need it" or YAGNI principle requires software engineers to work on functionalities when they're actually needed, not when they assume or foresee that something might be useful in the future. So why use the YAGNI principle in software engineering? The main goal of the YAGNI principle is to avoid spending time and money on over-engineering things that you think you will need later on. Because in the end, it usually turns out that you don't actually need it, or that what you need is different from what you expected. The primary benefit of using YAGNI is a more cost-optimized product implementation process due to better performance where the team focuses on delivering the current requirements effectively. They don't spend time and effort on guesses. It also provides more flexible codebase. You don't have to find ways to use suboptimal solutions that you had already implemented before you had the full picture. So when to use YAGNI? Apply this principle to avoid implementing features or code you don't currently need. An example of applying the YAGNI principle can be illustrated during the implementation of a new e-commerce platform, something like Amazon or eBay. Suppose the initial project scope includes basic functionalities like product listing, shopping cart, and checkout process. While brainstorming, the team might consider integrating a sophisticated recommendation engine that suggests products based on user behavior and purchasing history. This feature, while potentially valuable, is complex and time-consuming to implement. By applying the YAGNI principle, the team would decide against building the recommendation engine during the initial phase. Instead, they focus on implementing and perfecting the core functionalities that are immediately necessary. In this case, that would be the product listing, shopping cart, and checkout. The team would only consider implementing the recommendation engine in a future iteration if data and user feedback indicate a clear demand for more personalized shopping experiences. This approach prevents the team from spending resources on features that might not be needed immediately or ever, thereby saving time and money and reducing the risk of feature bloat. It ensures the project remains focused and lean, prioritizing direct customer needs over speculative functionality. So, the key essence of the YAGNI principle is: don't add features or functionality to our software that we currently don't need. Stick to what you know you need at the moment. Don't add code for the imaginary future. Let's move on to the KISS principle. According to the keep it simple, stupid principle, or KISS, the key to building a successful product is simplicity. The KISS method applies to the design and implementation of software or digital products, but it's also widely used in other fields, such as management or engineering. And the idea that it's generally more effective to keep things simple rather than complex is much older. Let's take this quote from Da Vinci as an example. He said, "Simplicity is the ultimate sophistication." KISS is also used as an acronym for keep it short and simple, keep it short and sweet, and keep it simple and straightforward. All of these variations refer to the same approach. The keep it simple, stupid, or KISS principle has a huge impact on overall product success. Users don't want to waste time. They expect a frictionless experience with straightforward, intuitive user flows, jargon-free naming, and quick results. A simpler software structure makes testing easier and more effective. Reduced codebase complexity makes maintenance easier and faster. So when to use the KISS principle? Use it to keep your code as simple as possible, avoiding unnecessary complexity. An example of using the KISS or keep it simple stupid principle in software engineering can be seen in the design of a user interface for an application. Let's consider a task management app, which requires a method for users to add new tasks. Instead of designing an elaborate multi-step wizard with numerous options for categorizing, prioritizing, and scheduling each task, applying the KISS principle would lead to the creation of a simple, straightforward interface. Here, users could add a new task with a minimal form, just a field for the task description and a submit button. Advanced options like setting priorities or deadlines could be hidden behind an optional More Options button, which users can click to access these features only if needed. This approach keeps the interface clean and uncluttered, reducing the cognitive load on users and making the application easier to use and understand. It simplifies both the user's interaction with the app and the underlying code, which in turn facilitates easier maintenance and fewer chances for errors. This not only enhances the user experience, but also aligns with the core functionality of quickly adding tasks, directly reflecting the KISS principle by focusing on simplicity and essential features. So, the key essence of this principle is don't add unnecessary complexity to our software. Instead of being too smart in your code, think about your colleagues and future teammates. Maybe it's better to write 2 to 3 lines more, but guarantee that your future teammates will understand it. Next, let's talk about the DRY principle. DRY stands for Don't Repeat Yourself and recommends reducing the repetition of software patterns. By eliminating redundancies in process and logic, engineers lower technical debt and improve the maintainability of the code, both of which are important cost factors, especially in the long term. What's important? DRY should be applied across the whole system, including not only in the codebase, but also in testing and documentation. The DRY principle states that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. This quote, by the way, comes from the book The Pragmatic Programmer by Andrew Hunt and David Thomas. It requires programmers to use abstraction to remove characteristics in order to be able to reuse an element in different parts of the application. So, how does the DRY principle benefit products? The DRY principle ensures that any modification of a single element of a system does not require a change in other logically unrelated elements. So it's an effective way of streamlining the implementation process. In addition, elements that are logically related change predictably and uniformly, which keeps them in sync. When to use the DRY principle? DRY can be used in almost all cases. If you see repetitive code or logic in your system, it might be a sign that you need to abstract or modularize that logic into functions or classes. An example of applying the DRY or don't repeat yourself principle in software engineering can be seen in managing user authentication across different parts of an application. Suppose a web application has multiple components that require user authentication, such as a login system, user profile page, and settings page. Instead of writing separate authentication code for each component, which can lead to redundancy and increased maintenance overhead, the DRY principle would guide the engineers to create a single authentication module or service. This centralized authentication service would handle all user verification processes and can be called by various parts of the application. Whenever a user tries to access their profile or modify settings, this service is invoked to check if the user is logged in and has the necessary permissions. By implementing a single authentication service, the codebase becomes cleaner, easier to understand, and maintain. If changes are needed, such as updating the security protocols or modifying the login mechanism, these can be made in one place, reducing the likelihood of errors and inconsistencies across different parts of the application. This approach not only saves implementation time, but also ensures that the system's security practices are uniformly applied, enhancing overall security. So, the key essence of this principle is don't duplicate code or data in our software. So, as an engineer, automate and reuse whenever you can. Lastly, let's discuss the easy to change, or as I like to call it, ETC or ETC principle. The easy to change principle emphasizes writing code that can be modified, extended, or refactored with minimal effort. It focuses on making software adaptable to future changes by keeping the structure clean, modular, and maintainable. The main goal of the ETC principle is to ensure that future changes or additions can be easily implemented without needing to rewrite large parts of the codebase. This improves maintainability and allows teams to respond quickly to new requirements or bug fixes. The primary benefits of using this principle include a faster implementation cycle. With a flexible codebase, software engineers can introduce changes more quickly without breaking existing functionality. Following ETC reduces the chances of accumulating poor coding practices that make future changes more difficult or risky, thus reducing technical debt. It also provides improved collaboration where code that's easy to change is easier for multiple software engineers to work on and maintain over time. So when to use ETC? Apply this principle to ensure that future changes or new features can be implemented smoothly without introducing complexity or breaking existing functionality. As an example, imagine you are implementing a content management system, or CMS for short. Initially, the CMS only supports text posts, but there's a possibility that in the future you might want to add image and video posts. Rather than over-engineering the system to handle all possible media types from the start, you could apply the ETC principle by designing a modular structure. Start by building the text post functionality in such a way that adding image or video post types later requires minimal changes to the core system. This keeps the initial implementation simple while allowing for future flexibility. So the key essence of this principle is make our code flexible and easy to modify. This leads to better maintainability and ensures that your codebase can adapt as new requirements emerge. In conclusion, software engineering principles are central to good software practice. They help software engineers write effective, maintainable, and reliable code. You aren't gonna need it, YAGNI. Keep it simple, stupid, KISS. Don't repeat yourself, dry, and easy to change, ETC or ATC, are some of the most powerful digital product design principles. They lay the foundations for best practices that software engineers use to build better products every day. The YAGNI, KISS, dry, and ETC principles are not just coding strategies. They're philosophies that guide crafting quality software. They're foundational elements for professional growth and efficiency, playing a crucial role in promoting clean, maintainable, and efficient code.